Today we are going to we are talking about solid two public spaces. First is the second one is creating a tougher office. Let me explain the problem to you guys. The problem is very simple. You are having a nums array which are going to be have some elements like let's take this example minus 1 0 1 and then 2 minus 1 4. So the problem says that you want to find indexes I comma j comma k. All these indexes should be different such that nums of I plus nums of j plus nums of k is equal to 0. Okay. For this problem, we are going to solve it for 0 because they are asking for this only. And okay, and we need to return all the possible numbers, right? Like here minus 1, 2. Okay, so all the indexes are totally different. Like this minus 1 is for this one, this minus 1 is for this one, and this 2 is for this one. So indexes should be different. Element can be same, but indexes I, j, k, they should be all different. First, we are going to solve for 0. Then we are going to extend it for any number x. Like let's say we are having a value x instead of 0. Then we'll solve for finding nums of I plus nums of j plus nums of k is equal to x. So first let's solve about 0. Then let's see what we can do for any number x. Hint for this problem would be binary search and two pointers. I've given you hints also. Go through the constraint, what constraint says, and yeah, take your time. It's 40. We can discuss at 44. We will discuss this problem at 44, 9:44. Okay. Those who have recently joined in the class, I'm sharing the problem link again in the chat. Try solving this problem, thinking about this, and we are going to solve it at 9:44. I'm going to discuss it at 9:44. Anyone having any idea? It's pretty normal problem, not even two pointer problem. Hint is just bare binary search, nothing else. Mhm. See, whenever okay, let me give you a tip. Whenever you think that whether your idea is correct or not, have an example uh, and try to think of a counter example. Okay. Counterexample means negative test case for your solution. Try to think that. How you can share, obviously. Hmm. 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 Okay. Okay. How would you find that? Uh, okay. Let me ask. How would you do that? That's a question. Like let's say, using first for loop, you got x is equal to 6. Now obviously you need to find y plus z is equal to minus 6, right? And suppose this is your I. Okay. And now my question is, how would you find y and j? Suppose you choose this as an I or this as an x. How would you calculate? Hmm. Okay. Now, what if you did not know? What if you did not? Then which pointer you will increment? Which one? Got it. That's correct. And one more thing. That's correct. Did you thought of binary search? And do you have proof why you are doing this? Why you are? Why this approach is correct? Do you have a proof for that? Okay. It's a basically problem called as two sum, right? X plus y is equal to some number x. You can easily find using two pointer when this array is sorted out. Okay. Okay. But this was not the intention to teach here, actually. Okay. Anyone else with some other ideas? With some binary search or something else? Anyone? No one, yeah? There's one person who told optimal approach, and there's no one who are having any approach. Fine. The problem is very simple. See, whenever reading a problem, first read the problem statement, then go to constraint. From there, you will get an idea ki in which time complexity you have to solve. Like here, nums is equal to, in this case, nums is equal to 3000. So whenever you have n less than equal to 3000 or 4000, you can solve it in big of n square or big of n square log n. As simple as that. As I told you already, right, that in 1 second or 2 seconds you can have at max 10 key power 8 operations in C++. In Java, you can have a multiplication of 3. In Python, you have a multiplier of 5. Okay. Okay. So now let's understand and solve this problem. It is very simple problem actually. The basic approach that everyone would be having, I guess, brute force approach, is quite simple. You would have a three for loop for I is equal to 0, I less than n, I plus plus. For j is equal to I plus 1, j less than n, j plus plus, for k is equal to j plus 1, k less than n, k plus plus, and if nums of I plus nums of I plus nums of j plus nums of k equals to in 0, then you would push it, right? You got index I and n, j and k, right? So this approach, I'm pretty sure that everyone would have got this approach, right? Everyone knows about this approach, right? Everyone is clear with this. It's a big of n cube brute force approach. This is what you will tell first in the interview. Whenever you're having an interview, you would first tell the brute force approach. Then you would pretend of okay, that you're thinking. Then you would tell that, hey, I'm thinking that this would be more optimal. Okay. Now let's go to optimal approach. Not optimal approach, better approach. Okay. Suppose, okay, let me ask you one thing. Suppose you are having an array, sorted array. Okay. And you let's sorted array 3, 5, 15, 20, 20, 24, 28, 30, 35, 38. Suppose you are having a sorted array and you are, suppose someone told you, hey, I want to find 35. Is 35% in it, yes or no? Yes, 35%. Suppose someone told you, hey, I want to find, by the way, uh, the person who told the previous approach, there was this one flaw in that. I would come to you. Suppose someone would tell, okay, let me ask you a question. Suppose someone asked you, tell the tell whether 35 is percent or yes or no. How would you do? You are given a sorted array and you are asked about any value x, that it is percent or yes or no. How would you do? Binary search. Simple. But suppose someone told you, let's say I want to count how many 20s are there, like x is equal to 20, and you want to count how many 20s are there. How would you do? Exactly. That is the number of 20s, right? Hmm. So, okay, now this is binary search. Now, think about this, what I'm doing. What I will do, I would first sort the array. Okay, let me sort it for this case. 0, minus 1, so minus 4, minus 1, minus 1, 0, and then I guess 1, 2. Okay, I've sorted this array. Now, I want to find three pointers, basically three pointers such that their sum is 0. As simple as that. So I would go to all possible two pointers. First, I would go to this I and this j. Now, as I've booked this I and this j, so my sum is minus 5. Minus 5 plus x is equal to 0. So my remaining element should be 5. Right? This should be my remaining element. Let's say what I'm trying to do. I'm trying to go to all pointers, all possible two indexes. For let's say I consider minus 4 and minus 1. So I want to find k index such that minus 5 plus x is equal to 0. So that x will be 5. It means that at that index my value should be 5. So how can I find it? How can I find it? I can find it using binary search, whether this array has 5 or not. Yes or no? Is it clear? You guys tell me. Is it clear? Kya? Okay. Okay. Let's say I'm having 5 here, two times. So now here your motive will not be finding x, or sorry. Okay, 1 minute. Mm, huh. Here one more thing. Your motive will not be just finding x. Suppose 5 is present. So you will have minus 4, minus 1, 5, 3 times, because you can form 3 pairs. So minus 4, minus 1, 5, minus 4, minus 1, 5, minus 1, minus 4 minus 1 5 three times. I j, this can be k, this can be k, this can be k. But there's a flaw here again. What flaw we are having? Let's understand. The flaw which we are having is, let's say, minus 4 minus 1 and my bad, 1 second. अगर मैं इसको ले लिया, 1 second guys. For this, okay, if I consider this, okay, it won't be considered. And previous one is one. Fine, fine. There's no flaw. There's no flaw. My bad. But there's a flaw. Let me tell you what flaw we are having. Okay. Let's say we are having this array. Okay. Let's say we are having this array. Let's say this is my I, this is my j. So what element do we need to find? So I have minus 4 plus 2 plus x is equal to 0. So x is equal to 2. So I have to find 2, right? So I'm having fixed minus 4 and 2 would be my first two elements. Now I need to find x is equal to 2. So you would find x is equal to 2 in this array. So you would say, hey, I'm having two twos. But there's a problem here. You cannot choose both twos because this is already chosen as j index. So you can choose only one two, right? So here you choose 0, 1, 2 index for now. But let's say this was not your j. Let's say this was your j index. Earlier you picked 0, 1, 2 indexes. Okay. Now let's say here you choose this minus 4 and this as a 2. Again you have to find x is equal to 2. So again you will say, hey, I have x is equal to 2 present here. So again you would choose 0, 1, 0, 2, 1. So if you see properly that you are choosing two same set of two same triplets of indexes, 0, 1, 2, 0, 1, 2. But here it is told that all the triplets, that notice that solution must not contain duplicate triplets. But here you are having duplicate triplets. So how we can avoid it? We can avoid it by by forward searching. By forward searching I mean that suppose this was your I, this was your j. So you will search k after j, and you will have I, you will have j after j. Sorry, you will have j after I. Let me tell you what I'm doing. So first you will have a I pointer. You will go to all possible indexes. That is all possible I. Then you will go to all possible j, but after I, so that you do not have any duplicates. Now you have to binary search for that x. X is equal to 0 minus nums of I plus nums of j. But that binary search should be after j. That it should start from j plus 1 to n. So that you have I comma j comma k as what you say. They should not be duplicated. So all this will be distinct. Now everyone is able to clear. Everyone is able to understand what I'm saying. Everyone. What was the problem here? Everyone was right. The problem here was कि I cannot randomly search for any. I cannot randomly binary search for any x value because there are chances that I can duplicate the values, and I do not want to have duplicate values. That's why I'm always forward searching. I'm searching forward only. My j would start from I plus one, and my binary search would start from j plus one to n. Now the second problem was, suppose for this case your I was minus 4, j was minus 1, so your x was 5. So you would have minus 4, minus 1, 5 three times. Now these are not same, these are different, these are distinct because indexes should be distinct. So your index was 0, index was 2, 3, 4, 5, 6, 7, 8. So all the indexes are distinct, all the triplets are distinct. So 0 to 6, 0 to 7, 0 to 8. So these were the indexes. So all the indexes should be distinct. Numbers can be same, like minus 4, minus 1, minus 5 can be same, but indexes should be distinct. So that was our problem. So I hope everyone is clear. So the logic is, first you would iterate from I is equal to 0 to n, then j you would start from I plus 1, so that should not have a duplicate j and I. Then you will binary search for x. Suppose you got count as let's say 3, and you know x, right? Your x is negative of nums of 5 plus nums of j. So your count is suppose 3. So you would make a vector, you made a vector, and you would push nums of I, nums of j, comma, num minus nums of I plus nums of j. This has 3 times. Now after pushing all this, you will get an you return that array, and that would be your answer. I hope everyone is clear with the solution. Everyone is clear with the approach. Anyone having any doubts? Kya? Okay. Anyone having any doubts in this problem? Anyone? No, right? Now let's. I would give this problem as a home assignment. This is the very first problem of late code. Two. It's very first one late code. That is two sum. It's very easy problem. I want you guys to do it on your own. I don't want to discuss in the class. But now, uh, coming to approach that was given by that girl, the problem in your approach is that you won't be able to find frequency of that, right? Suppose you have to find five, right? How would you find five 3 times? Can you tell me? Listen to some. Will you be able to find five 3 times? That was exactly the problem here. So that thing I don't think it will work. Fine. So should we move to another problem, kya, or do you want me to code it? What do you guys say? So what approaches I followed? Is this binary search one? Sum is called down to the ठीक है. No, it's a different approach. There's a binary search approach. Again, it's a different approach. Fine. I have different approaches here. So what you guys do you want me to code this problem, or should we move forward? Let's move to little bit tougher problem here. So number of subarrays with distinct k elements. I want you guys to look into this problem. It's a very nice problem, and it's pretty tough also. If you want to use maps, if you want to use anything, you can use it. But I won't advise you. But fine, go with this problem statement, and I'm going to code it. Don't worry about this. It's a pretty good problem, so I would be coding it. It's what is the time now? Time is 9:02. We can discuss it at 9:05 or 9:06. Take your time. We will discuss at 9:06. So everyone is able to understand the problem at least, right? Hmm. Everyone is able to understand, right? What problem is saying, what this problem is saying. I will give one hint. Try to solve for at max k distant. Here we are having exact k distant, right? Try to solve it for at max k, not exact k, at max k. See, if you are able to solve for at max k, then answer would be at max k minus at max k minus 1. That would be your answer. Try to think for at max k. So number of good arrays in which number of distinct integers is at max k. Try to solve for that. And this is the last problem that we are doing for two pointers. Then tomorrow we are going to start another topic. Okay. Tomorrow we can start. I guess what we can start. Tomorrow we can start maths. I'm thinking maths we can start. Or 1 second, give me a moment. Binary to pointers done. So tomorrow we'll start maths. Tomorrow again we are going to have interesting class. Anyone having any ideas? Any sort of ideas? Huh? So any difficulties you're having? Kya? Okay, this is the thing which I'm not able to find or something else. Something like that. क्या हुआ भाई इंटरेस्ट नहीं है क्या क्लास में? Okay, what is your Bluetooth? How would you calculate? Okay, so you're having a login factor extra, so n square login, right? So just one. How would you do it into n square? No, no, n square login. Right? How come, yeah? How come you're saying n cube? Suppose you start. 1 second, 1 second. Suppose you're starting from I, right? And you're going to check. So so I is equal to, let's say, you're starting from any I. I is equal to 0, I less than n, I plus plus. It means that your subarray start from I. As simple as that. You will make a set here, set in test tree. Okay, this will store all the elements. Now you would have a j is equal to I. It means that ending at j plus plus, j less than n, j plus plus. You would insert these elements, right? So st dot insert nums of j inserted. Now you would calculate size of set and how many elements are there. How many elements you know? J minus I plus 1. This is the number of elements such that your subarray start from I till j. You got number of elements. You got the size of set. Now you would check if st dot size equals to this j minus I plus 1. Then you would do count plus plus here only. So n square only, right? N square login. How n cube? Got it? And now the problem, follow problem which someone can ask, can you do it in big of n square? Or can you optimize it to big of n? Ha, someone was saying some approach. Mhm. Okay, okay, okay. Mm-hmm. Mm-hmm. Got it. So basically, now my problem would be how you're finding for at max k. I got it. At most k minus at most k minus 1 is exactly k. Right. I got it. But now the problem is how you're finding for at most k. Can you tell me? At most k minus 1 is equal to exactly k. You got it, right? It's pretty, I guess. You're having like, how you say, I'm having at max 5 chocolates, and someone says that, give me at max 4 chocolates. No, sorry, very bad example. How can I explain it? But I guess it's clear, right? So uh, take all the numbers till at max k. Take all the numbers till at max k minus 1. So obviously, if you remove that remaining set of k minus 1, you would obviously have a set of only k numbers. Something like that. Did you got this, kya? Did you got this point, Ashish? So who are you asking? Did you got this point? Mm, mm, exactly. Exactly. I would come to that point. I would come to that point in the last half, in the last part of the class, and I would give you. Mhm. Okay, 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 okay. Mm. Basically, you're saying you would go on increasing your j plus plus until the number of elements are basically until the map size is less than equal to, okay, right? What you're saying, and how you're calculating number of subarrays. I want to know. Suppose this is your I. Suppose this is your I, and this is your j. This is your last j till which you can go. Now I want to ask how you are calculating number of subarrays from I to j. That's my question. Next time, obviously, you would do I plus plus, but now the problem is how would you calculate? Okay, okay, let me, guys. Okay, let me before starting the problem, let's discuss this thing first. Okay, suppose I'm having an array starting. Okay, uh, let's say this is your starting point and this is your ending point. Let's say this, right? 0, 1, 2, 3, 4, 5. This is your ending point. I want to calculate number of subarrays from 0 till 5. Okay, number of prefixes. How can I calculate? Can you tell me number of prefixes from 0 till 5? How many prefixes you can have? One is this itself. Second is this. Third is this. Fourth. How many prefixes you can find? One, two, three, four, five, six. Right? You can find six prefixes, right? Suppose same thing. Are you able to understand, okay, what I'm trying to say? I'm saying that if I'm starting from 0 and my ending point is index 5, I want to calculate how many prefixes that can I have starting from 0. So one is 0 से लेके 0 तक, second is 0 से लेके 1 तक, third is 0 से लेके 2 तक, fourth is 0 से लेके 3 तक, 0 से 4, 0 से 5. So I can have six prefixes here. But let's say, like if you look into this, if this is my index I and this is my index j, So number of prefixes starting from index I till index j would be j minus I plus 1. This you have to remember always. You can look into this, right? Number of prefixes starting from I till j is j minus I plus 1. Is this clear, Kya? See, I was 0, j was 5. So 5 minus 0 plus 1, that is 6. And we were having also answer as 6 here. So you have to always remember this. Okay. Now let's start this. Let's start solving this problem. It's pretty interesting problem actually. The problem is, let's take an example. This one. 1, 2, 1, 2, 3. Now we would solve for at most k. Okay. I would solve for at most k. So my new problem statement is I want to find number of subarrays such that number of distinct element in that subarray is at most k. Let's say k is equal to 2. So this is okay, k is equal to 2. So if I take this as a subarray, so this subarray has only one distinct element. It fulfills a condition, so it can be one of the possible solution. Like this subarray, 1 comma 2. This has exactly two distinct element that is less than equal to k. Fulfills this. Let's say this subarray, 1 to 1. How many distinct element you are having here? Two, right? One and two. So two distinct elements you are having. So again, at most k distinct elements, fulfilling. Let's take this as a subarray. 1, comma 2, comma 3. So how many distinct elements you are having here? 3. And how much at max you can have? 2. So it does not fulfill the condition. So these fulfills the condition. This does not fulfill the condition. So I hope everyone is able to understand my new problem statement. What my new problem statement is. Now let's try to find how many subarrays we can have. So that we are having at max k distinct elements. Okay, is this clear, Kya? Okay. Now let's try to understand how we can find. And I would code it also. First we will do it in big of n login, then we'll do it in big of n. Okay. I'm having a map. Everyone knows about map, right? Map data structure. Hash map everyone knows, right? So I'm having a map. So I'm doing in perspective of C++ language. You can prefer it in your own. Int comma int mp. So this is a map, or you can say dictionary. You can say anything, or you can say list. Dictionary in Python and all. And yeah, I don't know about Java. So Java, you say hash map. This map will store frequency of this key. So if you say MP of 2, it will store frequency of 2 in current subarray. Let's say this is my current subarray. So if I say MP of 2, it will return me frequency of 2. So frequency of 2 is 2. So it will give me 2 in return. And everyone knows that map stores all map stores basically distinct key, right? So suppose your this array is having 2 comma 1 comma 2, and in map you would have mp of 1 is equal to 1, mp of 2 is equal to 2. So in this map you would be having like this. So when you do mp of size, it will tell you how many distinct elements you have. So you have two distinct keys. So mp of size would return 2, but the array size is 3. So I hope everyone is clear with this also, right? How what map size returns. So yeah, I hope everyone is clear with the basics. So let's start. So I'm having a map initially with no keys, no values. Okay, I'm having a count variable that is initially 0. That will store number of sub arrays that makes k distinct elements, and I'm having tail pointer here and head pointer here, like the previous class. Now, if I take this element, okay, my k is 2. Okay, if I take this element, so if I take this element, my MP of 1 would become 1. Yes or no? My MP of 1 would become 1. So if I take this element, and one more thing, take care. I will come to later on. So how many distinct element will I have? I will have one distinct element because map has only one element. So can I take it? Kya? Can I take it? Yes or no? I can have at max two distinct element. You guys are in the class, right? Huh. So if I take this element, my MP of 1 would become 1 and I would have only one element in the map. So can I take it? Yes, because I can take at max k distinct element. So I would take it. So my head will move to this pointer. Let's try to go to second. Can I take it? Kya? If I take it, MP of 2 would become 1. MP of 2 would become 1. Again, my map size is 2 and my k is 2. So I can have at max 2 elements. That is my map size. So I can have it. So I can have it. So my head will move to this pointer. Let's try to move to next point. If I move to next pointer, so my frequency of 1 would increase. But still, my map size is 2. So I can have it. Let's try to move it to next element. So my MP of 2 would be 2. Still, my map size is 2 and my k is also 2. So I can have it. Now, when I'm trying to move to next pointer, when I'm trying to move to next pointer, if you look into this, now there's a third element introduction. There's a third element introduction. If I take it, MP of 3 would become 1. Now my map size is 3. But I was allowed only to have 2 at max elements. So can I take it? No, right? So the largest subarray which I can have is from here. The largest subarray which listen carefully. The largest subarray which I can have is from here till here, right? Right? Yes or no? Now, you guys are very sure. If in the next iteration, you would, as you cannot move your head, so you would move your tail, right? You are very clear that in next iteration, you as you cannot move your head, so it's obvious you would move your tail. You would remove this element. So before removing this element, let's see how many subarrays you are having such that this is starting. So how many subarrays you are having such that this is starting element from here till here? Can anyone tell me? It's simple. One, two, three, 4. Or if I say head index minus tail index plus 1. We talked about this in the first half of this problem. Everyone is clear till this point? So your counter would increase by head minus tail plus 1. Everyone is clear till this point? Okay. So, and this MP of 3 is 1, it's not taken because I cannot move ahead. Okay. Now, as I cannot move my head and my head is here, so let's move our tail. If I move our tail, I left this one, right? This one should not be contributed now, right? Because this is my new subarray. So this one should be contributed kya? No, right? No, na. So I have to decrease its frequency. Now it will be 1. So this is my new tail. Now, again, we will try to move our head. So we moved our tail in the next iteration. We will try to move our head. So can I move my head here till here kya? Because if I take this element, MP of 3 would become 1. Now I have 3 elements in the map. That is not a good case because I can have at max k elements. So we will stop here. How? So again, we are having a subarray from tail to head as a valid. So how many subarrays we are having such that this is starting point. Again, head minus tail plus 1. Again, head minus tail plus 1. After taking the contribution, we will move our tail from till here. So again we will remove its contribution. So if we remove 1 2, so initially we were having two twos, now we are removing this 2, now we are only left with 1 2, that is this 2. Okay, so we are left with only 1 2. So my tail moved from here till here. So again, in the next iteration, can I move my head cap? If I move my head, I will have three elements. So again, it means that this sub only this sub array from here till here it is valid. So how many sub arrays you are having starting at this point? That is 2, 1, 2. That is head minus tail plus 1. So tail head minus tail plus 1 again, same thing. Now you will move your tail from here till here. So you would decrease one's contribution. So one's contribution is decreased. Now MP of 1 is 0. But 1 is still in the map, right? 1 is still in the map, right? Yes or no? 1 is still in the map. It means that 1 is still in the map, right? MP of 1 is equal to 0. It's still in the map. Ha. It means that if its frequency is 0, it means that that element should not be the part of map. So we will delete this key. Okay? Because its frequency is 0. We don't want it to be in map. Now, my tail is here. My head is here. Now I will try to move my head as long as possible. So if can I move my head to here? So MP of 3 is 1. My head will move to here. Now can it move more forward? No. So again I will calculate numbers so on so on. Now I hope everyone is able to understand the logic behind it, what I'm trying to say. It might feel tough to code, it might feel tough to implement, but yeah, be with me, I will help you in implementation also. So till this point everything is clear. Now again you would move your tail from here till here and then you would do the same thing. Let's try to code it. Let's try to code it what we have studied now. So int at most k. So I'm having an array of vector in terms. I'm having a value k. Now I'm having a value count, which will return me how much subarrays we are having. Like previous class, tail is equal to 0, head is equal to -1. While tail less than 1. Okay. Now I would I will try to find. I will try to I will try to move my head. I will try to move my head as long as possible. So while head plus 1 less than 1 and and okay, one more thing I want to have is maps. Map int comma int mp to know how much frequency we are having. Okay. Now okay. Uh, one thing, can we optimize it? Okay. 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 One thing. One thing. Instead of map, let's have a length variable. Int current length. Let's have this variable. Okay. This would help me a lot. So let's have a int current length is equal to initially 0. Let's have this variable. If suppose you are having a next element, now you will try to take this element. So let's say next element head plus 1 is, let's say head plus 1 is, let's say it is 2, and you are having 2 in the maps. So is that 2 going to increase your length क्या? At max k element, sorry, distinct element, let's say. So this variable will store number of distinct elements. So what I'm saying, let's say in map you are all, let's say in map you are having MP of 2 is equal to 2, MP of 1 is equal to, let's say, 4 already. Now your next element, head plus 1 element, is also 2, and your distinct element would be 2 because you are having two distinct elements, 2 and 1. So what I'm saying, if your next element is already in map, like 2, it is already in map. So is it going to increase the number of distinct element? Kya? No. Let's say your next element is 3. Let's say head plus 1 is 3. As head plus 1 is 3 and 3 is not in the map, it means that it is going to increase the number of distinct elements, right? In the subarray. Yes or no? Hmm. So let's try to do that only. So int increase is equal to 0. So it is increased by 0, let's say. If mp dot find, or let's say count only, head plus 1. Hmm. How do I say? Okay. And mp dot size plus mp dot count, that would be better one. Nums of head plus 1. Let me explain you. This mp dot count, uh 1 second, 1 second, 1 second, guys. Okay. 1 second. Someone came in the class. Just crunching. Okay. So one more thing. There's a property in map that is mp dot count. It takes a key and it returns 1 if that element is already there, and it returns 0 if that element is not there. Like in map, let's say we are having 2 and 1. So if I say mp dot find, mp dot count, let's say I do mp dot count 1, it will return me 1 already because 1 is already there. If I say mp dot count 3, it will return me 0 because 3 is not there. So it will return me 0. So this is key. So it will check for that key. So what we will do? We will do and uh, mp dot size plus, we will increase number of distinct element if that element is not there. So mp dot count nums of head plus 1. If it is 1, it returns 0, otherwise 1. Let me let me tell you what I've written here. So if that element is there, like let's say 1 is there, like if my head plus 1 is 1, so as 1 is already there, it should not it should not contribute it increasing of size map, so I'm returning 0. Let's say head plus 1 is 3, as 3 is not there, so it have to contribute, but mp dot count returns 1, so for that case I have to return, how to explain you here. See, mp dot count for 1, it will return 1 because 1 is there, but I don't want to take its contribution. I want to return 0 because I don't want to take the contribution of 1 because 1 is already there, so it is not going to increase number of distinct element. So if number is there, I will return 0. If number is not there, let's say 3, 3 is not in the map, right? We are having 2 and 1, 3 is not there in the map, so it is going to increase my number of distinct elements, so I'm taking 1 in that case. So I'm writing a ternary operator. If element is there, take its contribution as 0. If element is not there, take its contribution as 1. Did you got my point now? This is what I'm writing. It was pretty difficult to write. Fine. Okay. If that is less than equal to k, I would take that element. So uh, I would take that element head plus plus, and I would take that element into my maps also. I would increase its frequency into my maps also. Now, suppose you move to the last index, you move to last possible head. You would increase your counter variable, count plus is equal to head minus tail plus 1. Now, you would move your tail plus plus. Before moving your tail plus plus, as I told, you have to decrease its contribution. So, mp dot nums of tail, uh, okay, let me write it tail and head, mp dot tail minus minus, and if that element is 0, if it consists 0, if mp of nums tail equals to 0, I have to remove it from the map. So mp dot erase, mp dot find, or let's say nums of tail, I'm just removing it from the map, as simple as that. After removing, I'm doing tail plus plus, that's it, and return count, as simple as that. The thing which I explained to you, first I would move my head as long as possible after taking this conversion. So I'm having head as some, I'm having tail as some here, and I'm having head as somewhat here. So my number of sub arrays from tail to head, such that tail is starting point, is head minus tail plus 1. Now next time I will, as I cannot move my head forward, so I'm moving my head little bit one step forward. So if I'm moving my head from here till here, first I have to remove the contribution of this. So I remove the contribution of this, and now suppose this element is 0, its frequency is 0. So I have to remove that element from the map also, right? So that it does not increase the size. So if that element frequency is 0, I'm removing that element from the map itself, and then I'm increasing my tail plus plus. I hope everyone is able. I hope everyone is able to understand till this point. Yes or no? Now, as I told you, your answer would be int answer is equal to at most k minus at most k minus 1 return answer. Let's run this, and it will give you a wrong answer. I know. At what point it will give you a wrong answer? Mm, okay, it will be a tail here, and int n is equal to nums dot size. अरे यार, head minus tail plus 1. Who came at this point? Okay, sorry, my bad. I am passing nums and k, so I should have to pass nums and k. Nums comma k, nums comma k. Let me run it. Let me submit it. Okay, one more thing. It is going to fail. I will ask you why. Wrong answer. In Friday's class, I told you what wrong answers we are going to have. Do you even remember what we discussed in the Friday's class? One edge case. Hey, if my tail is greater than head, it means that it is not possible. Else we are going to do this. If my tail is greater than head, it is not going to be possible. Okay, yeah, it would be, let's move our tail plus plus, and sorry, head is equal to tail and tail plus plus. Use test. I will explain you what is the issue here. Let's submit it. I will explain you. 1 second, let me submit it. Submit हो जाएगा. What is happening here? It got accepted. Let me explain you what was the problem here. What we are doing here, let me explain you. Okay. Uh, you were able to understand earlier, right? If I remove this and if I just have this, right? If I don't have if else, if I'm having just this, you are able to understand, right, what I'm writing here and what I mean from here, right? Everyone is able to understand, right? Anyone having any doubts still here? What I'm trying to do? No, right? Anyone having any doubt? No. Now, can anyone explain me what I did here? Let me explain you. Let's say your k was 1. What you will do? So, at most 1 you can solve. So, your answer would be at most 1 minus at most k minus 1, that is 0. So, how would you get for at most 0? It is not possible to solve for at most 0, right? So, one edge case you can have, one edge case, let me remove everything. One thing which you can write is ki, hey, if my k is 0, if k equals to 0, return 0, because I cannot have any subarrays with number of distinct element at most 0. One thing which you can do here, this will also work. But I have written a generalized solution, I would tell you. It also got submitted. But I have written a generalized solution so that you don't have to worry about any edge cases. For this problem, you are able to find. For this problem, you are able to find, right, ki at most 0, how would this 2 pointer even work? It will not work because your head will always not move. Let me explain what I want to say. Your initially tail was here, okay? Your head was here, and your k was 0. How would you find for at most 0? You cannot find. You cannot move your head to here also, right? Are you getting my point? For at most 0 element, your head was initially minus 1, and your tail was at 0. You cannot move your head to here because if you take this element, you would have one distinct element. But you are not allowed to have even one distinct element. You are only allowed to have at most 0. So it is not possible even to move your head. Did you got my point? So whenever you find any cases such that your head is less than tail, it means that it is a negative test case. So whenever in that case I will not have any count or something like that. In that case, I will shift this. I will move my tail to here and I will move my head to here. So head is equal to tail and tail plus plus. So I moved my tail to here and head to here. Because it is head behind the tail is not possible condition. So if it is a valid case, then I am doing the rest of the stuff. It is a valid case. I will take the count and I would decrease the frequency of that tail. I would remove that element if it is 0 and I would move my tail forward. As simple as that. I hope everyone is able to understand this. Now this was a pretty standard and this was a pretty good problem here. Everyone got the solution, right? Anyone having any doubts till now? Who were answering me? There was one girl and this one boy. I don't know your names. Okay, Jashkaran and Salwa. Okay, fine. Now this problem is of n log n because in math we fetch in log n operation. Now if someone says you that hey, you have to do it in big of n, how would you do? Big of n. Suppose someone asks you, hey, you need to do it in big of n time complexity. How will you do? Look into the constraint. Look into the constraint carefully and think about the purpose of map. What was the purpose of map? What map was telling me? And is there any replacement of map that we can use so that it decreases the time complexity? It optimizes the solution. And map was also helping us to know the number of distinct elements. So if we are able to do these two operations that store the frequency of each element and store the number of distinct element without using of map, we can replace it, right? Are you getting my point, everyone? Salva, are you getting my point? If you look into the constraint carefully, the constraint says that each element in nums is going to be at max 2 into 10 ki power 4. So what I'm thinking of, ki hey, and each number is positive. What I'm thinking of, ki I will make an array because in array you can access the element in big of one operation. So I will make an array count frequency of 10 ki of 2 10 ki power 4. Uh, Fine. This map, this array will work same as map. So it will. So whenever you're taking any element into consideration, you would do count frequency nums of I plus plus. When you're removing any element, count frequency nums of I minus minus, decreasing the frequency. But now you guys would tell me, hey, how are you going to store number of distinct element, right? How I'm going to get to know कि नंबर ऑफ डिस्टिंक्ट एलिमेंट क्या है, क्योंकि इससे बस मैं फ्रीक्वेंसी स्टोर करता हूँ, राइट? इससे मैं वो स्टोर नहीं करता कितने डिस्टिंक्ट एलिमेंट है. फॉर दैट आई एम हैविंग अ डिफरेंट वेरिएबल. लेट्स से int distinct element is equal to 0. So let me replace it here. Distinct element plus. अच्छा, अगर कोई एलिमेंट नया इंट्रोड्यूस हो रहा है, लेट से हेड प्लस वन नया इंट्रोड्यूस हो रहा है, तो मेरे डिस्टिंक्ट एलिमेंट में मुझे कैसे पता कि ये एक नया डिस्टिंक्ट एलिमेंट है या पहले से एरे के अंदर है? हाउ वुड आई गेट टू नो? बताओ मुझे. वन से ज़्यादा है कि नहीं, ऐसे मतलब वन या वन से ज़्यादा कि नहीं. सो वही चीज़ लिख रहा हूँ मैं यूजिंग टर्नरी ऑपरेटर. काउंट फ्रिक्वेंसी नम्स ऑफ हेड प्लस वन. अगर ये वैल्यू नॉन जीरो है, इट मीन्स दैट ये कंट्रीब्यूट नहीं करेगा, इट इज ऑलरेडी कंट्रीब्यूटिंग इन डिस्टिंक्ट एलिमेंट. सो इफ इट इज नॉन जीरो, आई वुड रिटर्न जीरो. इफ इट इज जीरो, आई वुड रिटर्न वन. सबको समझ में आया चीज? वॉट आई एम ट्राइंग टू से कि इफ दिस एलिमेंट, अगर इस एलिमेंट का फ्रिक्वेंसी जीरो है, मतलब ये एलिमेंट पहली बार आया, राइट? इट इज गोइंग टू इंक्रीज माई नंबर ऑफ डिस्टिंक्ट एलिमेंट. तो मैं वन रिटर्न करूंगा. अगर इस एलिमेंट का फ्रिक्वेंसी जीरो नहीं है, लेट्स से टू या थ्री है, कुछ भी है, इट मीन्स दैट इट वाज ऑलरेडी इन आर एरे कंसिडरेशन. इन दैट केस ये डिस्टिंक्ट एलिमेंट नया नहीं है, इट इज ऑलरेडी देयर इन द एरे. सो आई हैव रिटन जीरो हियर. सो दिस इज हाउ टर्नरी ऑपरेटर वर्क्स. तुम यहाँ पे कंडीशन लिखते हो एंड यू रिटर्न अ सेमी कॉलन, कॉमा, ट्रू के लिए क्या रिटर्न करना है, फॉल्स के लिए क्या रिटर्न करना है. एंड ये यहाँ क्या करेंगे, इधर करेंगे सेम जो हम लोग कर रहे हैं मैप की तरह. यहाँ पे एक हल्का सा डिफरेंट होगा कि अब मैं ये देखो यार चीज. सो आई वुड डू, अगर उस एलिमेंट का फ्रीक्वेंसी जीरो हो जाए, आई वुड डिक्रीज माई डिस्टेंट एलिमेंट हियर. डिड यू गॉट माई पॉइंट? समझ में आया कि अगर उस एलिमेंट का फ्रीक्वेंसी जीरो हो गया रिमूव करने के बाद, तो मैं डिस्टेंट एलिमेंट से एक कम कर दूंगा. क्योंकि सपोज मेरे पास एक ही टू था और वो टू टेल, जिसे मैंने टेल को आगे बढ़ाया, वो टू हट गया, तो डिस्टिंक्ट एलिमेंट एक कम हो गया, राइट? सो आई वुड डू डिस्टिंक्ट एलिमेंट. और यहाँ पे भी एक काम करेंगे, डिस्टिंक्ट ये सेम चीज, डिस्टिंक्ट एलिमेंट प्लस इज इक्वल टू ये सेम चीज जो मैंने यहाँ पे किया. ओके, आई होप एवरीवन इज एबल टू अंडरस्टैंड दिस पॉइंट. मैंने मैप को रिप्लेस किया, कुछ नहीं किया, एरे से किया, बस हल्का सा ऑप्टिमाइजेशन है. इट इज ऑफ विब ऑफ एन लॉगिन. एंड आई होप दिस प्रॉब्लम माइट फील टफ टू यू, बट इट वाज नॉट दैट टफ. एक बार वापस समझाता हूँ मैं कैसे मैंने क्या किया. वापस देखना. आई वॉज हैविंग अ टेल एंड हेड पॉइंटर. ठीक है. मैप्स let me teach you from of that map approach only because अरे वाह तुम लोग को थोड़ा सा डिफरेंट डिफिकल्ट लग जाएगा. 1 second. You guys are in the class क्या मैं नेट पे चला क्या. I don't know what happened with the late code, but let me explain it here. I am having an array. ठीक है. मेरे पास एक टेल है और एक हेड है. I am continuously increasing my head pointer until number of distinct element is at max k. Till that point I am increasing my head pointer. Now जैसे नंबर ऑफ डिस्टिंक्ट एलिमेंट, मतलब मैं आगे हेड को नहीं बढ़ा सकता. दैट इज या तो मेरा हेड ही खत्म हो गया है या फिर डिस्टिंक्ट एलिमेंट मेरा कैसे बढ़ जा रहा है. इन दैट केस आई कैन नॉट मूव माई हेड. इन दैट केस आई एम हैविंग, सपोज मेरा हेड लास्ट यहाँ तक मूव किया, देन आई एम कैलकुलेटिंग नंबर ऑफ सब एरेस यहाँ से लेके यहाँ तक सच दैट दिस इज माई स्टार्टिंग पॉइंट. सो तुम लोग को बताया मैंने दैट इज हेड माइनस टेल प्लस वन. सो आई एम कैलकुलेटिंग इट हियर. इसके बाद नेक्स्ट आई एम मूविंग माई टेल फ्रॉम हियर टिल हियर. देन आई एम रिमूविंग इट्स कंट्रीब्यूशन. सो मैंने इसका कंट्रीब्यूशन रिमूव कर दिया. सो दैट आई एम डिक्रीजिंग द फ्रिक्वेंसी ऑफ दिस एलिमेंट. अगर इस एलिमेंट का फ्रिक्वेंसी जीरो हो गया, लेट्स से सपोज it 2 था और MP of 2 suppose let's say 1 था, when I moved my tail from here till here, then I would decrease the frequency, so MP of 2 would be 0. It means that मेरे नए सब array में एक भी 2 नहीं है. So this 2 should be removed from the map, right? But map का size में 2 contribute करेगा. This 2 should be removed, right? So I will do यहाँ पे वही distinct element हटा दूंगा, फिर 2 को remove कर दूंगा map से. Then I would increase my tail plus plus from here till here. As simple as that. Now this function will give me number of subarrays with at most k elements. और हमें exactly क्या चाहिए? Answer would be at most k minus 1. I hope everyone is able to understand till this point. किसी को कुछ भी डाउट है तो पूछो. किसी को कुछ भी डाउट है तो पूछो. Mem set. Okay. Do you use C++? Which language do you use? Okay. Forget about this. It is just setting this count frequency to 0. भाई सबका इनिशियली वैल्यू 0 होना चाहिए, राइट? बिकॉज देयर इज नो एलिमेंट इनिशियली. नाउ मैंने एरे यूज किया विच, बस ये समझ लो. अभी अभी मैप्स के लिए समझ लो. डू नॉट वरी अबाउट एरे. इट इज जस्ट लिटिल मोर ऑप्टिमाइजेशन. और इसका टाइम कॉम्प्लेक्सिटी बिग ऑफ एन लॉग इन विदाउट एरे. विद एरे बिग ऑफ एन. हमने कल ही डिस्कस किया था फ्राइडे में कि व्हाट इज द टाइम कॉम्प्लेक्सिटी ऑफ 2 पॉइंट अप्रोच. आई डोंट नो व्हाट हैपेंड टू लिट कोड. इट इज स्टिल स्टक, बट फाइन. मेरा लैपटॉप बहुत है. फाइन. सो किसी को अभी भी कुछ भी डाउट है तो पूछ लो. Anyone having any doubts? No, right? So from tomorrow, what I'm thinking to start is maths. From tomorrow, we are going to start maths, number theory specifically. That is also asked in the, that is generally asked, not asked in the interviews, but how? Okay, let's skip number theory for now. From tomorrow, we will start recursion. Okay, so we'll start recursion from tomorrow onwards. I would share that into group also, and I would share some problem link in the group also, so that you can have a hands-on on 2 pointers and binary search. So that's all about today's class. See you guys tomorrow. Okay. Do not worry, I will share the recording. Sorry, I forgot yesterday. Yeah.